Hey guys, we are going over lesson 13 in geometry today. All right, what we're going to be looking at is the area of a circle and the area of an ellipse. All right, if we have our circle, all right, remember with the circle we have a radius. All right, if I draw 4 radius here, I can take those radius and create squares out of them. All right, so I've taken my circle. I have 4 radius. I've created 4 squares. All right, this is a radius length here. This is a radius length here. All right, so if I look at this, the area of a small square equals the radius of the circle squared. Okay, 4 of those small squares equals the large square, right? So the area of the large square equals 4 times the radius squared. 4 times the radius squared equals that entire big square. So you look at the circle inside of that, and you see that the circle takes up almost all of those 4 squares, but not quite all of them. The circle actually, if we look at the single squares, it takes up a little more than 3 of those single squares. So the area of the circle actually equals 3.14 of those small squares. All right. So the area of the big square is 4 of the small squares. The area of the circle is 3.14 of the small squares. And a single small square, the area of that is side times side, length times width, and the length and the width are both the radius. So it's the radius squared. Okay, so that we would say the area of a circle equals 3.14 times the radius squared. We also call that pi r squared. All right, so that's going to be the area of our circle. So if we have a circle, all right, and the radius of the circle is 6, then we're going to do 3.14, all right, and then it's going to be times the radius squared, not times 6, not times 12, but times 36. And think about the fact that this is 6 inches, right? So 6 inches times 6 inches equals 36 square inches, right? So this is 36 inches squared or squared inches. If I multiply those out, I find that the area of this circle is 113.04 square inches, not the actual area of that actual circle because the radius of that is not actually 6 inches, but anyhow. All right, so let's look. If I have a circle and the radius of the circle is 4 inches, I'm going to do this 3.14 times 16. Make sure you square that in there. All right, and that's going to give me 50.24 squared inches. Okay. All right, that is our area. Now what we want to look at is the circumference. All right, the circumference of a circle, all right, is the distance around the circle. It's going to be this outside of the circle. Okay, the inside is the area. The outside is going to be the circumference. Okay, so the circumference is going to be pi times the diameter, or pi times 2 times the radius. So 2 times pi times the radius, or pi times the diameter is how we're going to calculate the circumference. So if I've got a circle and my radius here is 5, okay, I'm going to do 2 times pi times the radius, or 10 pi. All right, so then you could take that and calculate that out further and do the actual 10 times pi, and that's going to give you 31.4. All right, if I've got a circle and my radius is 4, this is going to be 3.14 times 8. Make sure you multiply this by 2. So notice that right here with the circumference, we get 2 times pi times the radius, or you could look at it as circumference equals pi times 2 times the radius, where the area equals pi times the radius squared. Make sure with the circumference it's 2 times the radius, where the area is the radius squared. So there's going to be a difference there, right? Okay, so up here, this is going to equal 25.12. And so as you're thinking about the circumference, we can just say pi times the diameter, or the circumference equals 2 times pi times the radius, because the diameter is 2 times the radius, okay? The area equals pi times the radius squared. These right here tend to be the two that I work with, and I tend to think with this one right here that A comes first, and then, if we were alphabetizing, then A would come first, C would come second, and circumference begins with 2. So that's how I tend to keep those two straight. Okay, as long as we're talking about circumference here, they want us to go ahead and talk about latitude and longitude. All right, so as we look at our Earth, okay, we have, our Earth. Well, the circumference of our Earth, going around the center right there is the equator, and that's going to be a line going across there. And this is what we call a line of latitude. All right, and the equator is an actual, the actual circumference of the Earth, because it circles the Earth, right there, right around the center. Okay, and as we're measuring our lines of latitude, what they do is they've drawn a line right across the center, right around, representing the equator. And if you took a protractor and you set it right on there, that would be 0 degrees on the protractor. Well, you know how on the protractor you would get 0 degrees, and then you get 10 and 20 and 30 and 40, and that would just keep progressively going up. Okay, and you would go all the way up to where you had, 90 degrees right here. That'd be 80 and 70 and 60 and 50 and 40, All right, well, we've got these lines of latitude that measure each of those degrees. So they have, we would have these lines, and they're all 10 degrees apart. And that helps us figure out how far north and south are you. Am I 10 degrees north? Am I 20 degrees north? 30 degrees north? So north of the equator, or 10, 20, 30 degrees south of the equator. Okay, and so just the center one, only the equator is an actual circumference. The other ones, each of those lines are going to be smaller because they're going across a smaller part of the Earth. Okay, so we have lines of latitude. We also have lines of longitude. All right, lines of longitude are all actually the same length. They're going to be a little bit different. Lines of longitude start at the North Pole, and they're going to go down around and theoretically go all the way around and circle from North Pole all the way around back to south, back up to north. Okay, and these are going to keep moving around like this. Okay, and there's going to be a degree of separation with each of these lines, so that this one right here that goes through Greenwich, England, okay, these are our longitude lines. All right, and this one that goes through England right here is 0 degrees, and then, we would have 10, 20, 30, 40. Okay, so as we're looking over here at this, we could have located right here, say, you're at 0 and you're up here at about 50. So if I had that I was 50 degrees north and, let's put this over here. right there, and you could be 10 degrees west. Okay, and that would be, somewhere like Ireland or something. It's going to be a little further to the west, roughly. So that's how they use latitude and longitude lines. Longitude lines are all circumferences. They're just circumferences that just keep shifting by 10 degrees. Okay. With the latitude lines, only the equator is a true circumference because all the other ones keep going up and they get smaller and they don't actually measure the actual length around the Earth. Okay. One other thing that we have that we're going to look at in this lesson is an ellipse. An ellipse is going to be an oval. Okay. And we could construct that oval as you're looking at constructing that. If we were to take two pens and we were to take a piece of string and put a piece of string between the two pens, okay, and we had a pencil here in the middle of it, and we could take and we could move the pencil as the string would allow us to move it, it would draw a shape that would be like that. That would be an ellipse. And this ellipse is actually going to have two center points. There's a center of the ellipse here, and there's the center of the ellipse there, is how that would be drawn. Okay, so as we're looking at an ellipse, if we're looking to find the area of an ellipse, we would take our ellipse and we would draw it on a coordinate plane. So here we have our coordinate plane, we have our x-axis, and we have our y-axis. And if we took our ellipse and we put it on there, okay, it would be centered up better than mine is currently. All right, but say we could take and we could measure how far is this from each side. What's the length of this? We'll say this is 4 here and this is 4 here. So my total length here is going to be 8. All right, we'll say this right here measures out to 3 and this right here measures out to 3. So my total width here is going to be 6. All right, we call these different lengths. We've got the major length and then the minor length. Okay, so this down here is going to be my major. This over here is going to be my minor. All right, so when we look at an ellipse, okay, major runs this way. All right, minor runs this way. Okay, so when we're finding the area of an ellipse, we're going to have the major divided by 2 times the minor, also divided by 2, and we're going to take that times pi. And this is going to equal the area of the ellipse. Okay, so here my major is 8 divided by 2, my minor is 6 divided by 2, and then my pi, then I'm going to have pi. Okay, so 8 divided by 4 times 3 times pi. So I'm going to have 12 pi. And you can go ahead and calculate that out to actually find what that would wind up being. So if I take 12 times 3.14, I'm going to get 37.68. Okay. If I had another ellipse, all right, and I said that here is this ellipse here. We've got this. This is 5. And this is 5. And say this is 2 and this is 2. Okay. So my major is 10 and my minor is 4, right? Divided by 2, divided by 2. So this right here is going to actually be 5. This right here is going to actually be 2. And then I'm going to take those 2 by pi is going to be 31.4. All right. So that's how that is going to work out. All right. I hope you guys have a great week.